Alrighty, so we're going to look at, we've done law of sines and cosines to find missing sides and angles of triangles. I missed your whole table. Right around you. Thanks. There you go. Now you have it. So now we're going to look at the area of a triangle. You've known how to find the area of a triangle for a really long time. That is not something that you actually learn in geometry. You learn it first like in 6th grade or somewhere way back then. But what this is just a capital A to represent area, little subscript of a triangle to distinguish between what we're finding the areas of. And your good old area of a triangle formula is what? Yes, but that one really should go in the trash can. 1/2, yes. 1/2 base times height. Base times height over 2, I know that you learned that probably in junior high at some point, but really when the numbers get a little stranger, having it like that is probably not best. It's like this. And that is a lowercase b and a lowercase h because they mean different things, right? Okay, so we can use trig to find the area of a triangle without knowing the base and the height. Okay, maybe I don't know both of them. Maybe I don't know either one of them. And we're going to come up with the first formula, and then I'm going to show you another one and probably show you how to get another one, but not make you write it down. And then the last one, the proof for that one is like crazy long, so we're not even going to look at that one. But so if I have this triangle, let's say that I am given the base, which this is the capital B, so across from that, lowercase b. I'm given angle C, and I'm given side A, which is across from angle A. Like, those are the things that I'm given in order to find the area of the triangle. Well, I know that to find the area of the triangle, the only way we know how to do it right now is 1/2 base times height. Okay, so we know the base. That's good. I don't know the height. We'll go ahead and label it in here. Are we capable of finding the height, though? Could we use some trig to find the height, just totally separate from that? If we look at this as a right triangle, right, isn't the height related to this angle somehow? And to this side? So if I look at this as a little right triangle, and this is the angle I'm using, what side is this related to that angle? Opposite, adjacent, or hypotenuse? Opposite, and this would be the hypotenuse. It is adjacent to it technically, but the fact that it's the hypotenuse trumps that. So we've got the opposite and the hypotenuse. Which trig ratio is that? Sine. So I can take the sine of C. That's equal to the opposite, which is h, over the hypotenuse, which is a. So since it's the height that I'm looking for, I can solve for the height pretty easily. Height is equal to a times the sine of C. Everybody with me? So now I can take this, and I can substitute it in right here for h. And then the area of the triangle, based on what I actually have, is 1/2 times the base times a times the sine of C. And it's okay that I don't know the height. Right? That's if I'm given a side angle side type of situation there. Everybody okay with that? So this gives it to you all in one step. Could you find the height and go substitute it back in, kind of like how we came up with the formula? Yes, you totally could, but the idea is to get formulas that work so we don't have to go find different pieces of them. So here there are going to be 3 different formulas. Right? So this first one is based on you knowing the side angle side information. Side angle side. Which in this particular case would be little a, little b, and angle C. So that would give me the area of the triangle is equal to 1/2. Now I have b times a times the sine of C, which is fine, but the formula really goes a times b times the sine of C. It's alphabetical. Not that you always have the alphabetical information, but it's the 2 sides and the angle. Notice none of those letters match. That's why it's the side angle side. If it wasn't, then I'd have other side links in there somewhere. Easy enough? Okay, 1/2 a times b times the sine of C. So let's say that I don't have side angle side, that instead I am given the angle side angle, or even the angle, side information. Okay, let's say I'm given one of those. Then I don't have the two side links to substitute in, but I do have an angle I could use. Can I find a second side? How could I find, so that I could have a side angle side situation, meaning that I can either find this side length or, well, actually that side length on either one of them, really. Are you capable of doing that? How could you do that? Law of sines, right? When the law of sines do that. So I'm going to show you where it comes from. You don't have to copy this down. If you decide that you knowing this really, really helps you, then you can always go back and write it down somewhere else. I didn't give you room for it. I don't know that it's necessary that you have this written down. I just think it's good that you know things don't just magically appear all the time. So this is what I have here. So let's say that they give me this information. Okay. So what I need in order to use that 1/2 A times B situation, or if this is the one I'm using, area of a triangle is equal to 1/2 A times B times the sine of C. Well, if this is what I'm given, my problem is that I know C, I know A, but I don't know little b. But I can find little b, right? So if I go and do that, I can do that the sine of B over little b equals, well, the C is the other one that I have, sine of C, oh, actually, I take that back. I don't want to do sine of C. I want to use the A that I have. Whether I use C, I don't know that side length, right? Is it easier to find this side length or this angle? The angle. So whether I'm given angle, side angle, or angle, angle, side, either way, I need to go find this angle, which I could do pretty easily, right? So I'm not going to actually do that, but I'm going to do that. But we can find that easily. So then the sine of A, which I would know, over little a. If I use C, I'd have to find the side C, and I don't have the information for that just yet. So once I do this, I can multiply. A times the sine of B equals B times the sine of A. Okay, so B is the one that I don't know. So if I divide this out, I get that B is equal to A times the sine of B divided by the sine of A. You with me on where it came from? Remember, you don't have to recreate this. This is just how we're getting this. So I'm going to take this, and I'm going to substitute it in right there. So that's going to give me that the area of my triangle is equal to 1/2 times A times, instead of B, I'm going to use A times the sine of B over the sine of A times the sine of C. So I'm going to take these things that are fractions and put them over 1. So that when I multiply all that together, I get A squared times sine B times the sine of C all over 2 times the sine of A. Okay. Again, you don't have to recreate it, just can you stay with me, see where all that came from? Because this is your other formula, which looks a whole lot worse than the other one, but it's really not that bad. It's the side length that you have squared times the sine of the other two angles over 2 times the sine of the angle that matches that side. So it's really not bad as far as how you just write it. I know it looks like crazy yucky, but it's not that bad. So that's what this second one is. If I am given either one of these pieces of information, okay, where in both cases this would be my A here, I'd have to find that third angle, which is a piece of cake, right? And then the area of the triangle is equal to whichever side you know. In this case, we're using A. That's what the generic formula says. But the side you know squared times the sine of one of the other angles times the sine of that third angle. Neither one of these angles matches this side. Over 2 times the sine of the angle that does match that side. Worst case scenario, if you only remember one formula, you can use this formula and you can use your law of sines or cosines to find your missing parts and still go back and do it, right? These are just the formulas, like if you want to do it all in one step, you can just do it that way. But I could have just gone off to the side, used the law of sines, found B and substituted it into here, or even found the height and substituted it in as well. Okay. This third one, I'm not going to show you where it comes from because the proof is like super weird long. But let's say that I give you, instead of all that, give you all three sides, okay, which is going to give you a side, side, side situation, which means that you know little a, little b, and little c. We don't know any angles. Here's what the formula looks like. Area of the triangle is equal to, it's a big old square root. And then it is s times s minus little a times s minus little b times s minus little c. So tell me what you're thinking right now. What the heck is s, right? It's a good thing to think. So here's what s is. S is 1/2 a plus b plus c. So tell me, if I find a plus b plus c, what does that give me about the triangle? It's the perimeter, right? And so I'm taking half of it. So the reason that there is an s here is what this actually is what's called the semi-perimeter. Okay? Semi meaning half. It's the half perimeter. Now this one looks all crazy weird too, but if you can remember how to find the semi-perimeter, then this isn't that bad. It's a semi-perimeter times the perimeter minus a, the semi-perimeter minus b, times the semi-perimeter minus c, take the square root of the whole thing, okay? But could I find an angle here and then also use the side angle side one that I knew already? Yes, I could use the law of cosines, I could find an angle, make sure I save it, and I could still use that first one. So you can always go back to that first one, which really it all goes back to the formula that you've known forever. You just have to use this law of sines or cosines to get you there. If you know these formulas, it just saves you steps is all that's really happening. Okay, we all good? Easy enough? All right. So we're going to try and use the formulas that go with it instead of trying to revert back. But I just want you to think, just because you have all these, if you don't always remember them, there's always other ways to get what you need. So here's this triangle. We're always going to draw our picture, right? So this is RSW. It's not even giving me like ABC. That's okay. Oh, and then it says with A, B. Oh, dang it. Okay, well, I just realized I copied and pasted that, and that is what that says, and that's not good. Well, it doesn't really matter, does it? Does it matter at all? No. So we'll just go in alphabetical order, I guess. We'll make A equals 5, B equals 9, and C equals 8. It's very strange. I did not catch that. I just did my little thing. All right, but this is the side, side, side situation, right? So if it's all three sides, that's the one that uses the semi-perimeter. Right? So my area of my triangle is equal to the big old square root of s times s minus a times s minus b times s minus c. So I have to find s. S is equal to 1/2 of 5 plus 8 plus 9. So what is s equal to? Gives me half of 22, which is 11. Yes, thank you. So when I go and substitute this in, the area of my triangle is equal to the square root of 11 times, oh, dang it, stupid badge, times 11 minus 5 times 11 minus 8 times 11 minus 9. And you can substitute all that into the computer, listen to me, into the calculator at once, or you can simplify a little bit. That's 11 times 6 times 3 times 2. Then you can let the calculator do the rest as long as you can type it in correctly. What do we get for the area of the triangle? 900. Did we have units? That drives me nuts. Okay. On area, I do want you to have units squared. I'm 99% sure when I made the assignment, it has units on it. Yes, it does. So make sure your units are squared. Okay. Everybody good? Easy enough? All right. This is really just, here's the formula, substitute it in. You don't have to go and find a whole bunch of other stuff because we have 3 different formulas. And so then here, triangle ABC A, B, C, with A being 3, little b being 2, angle C being 110. So this is your side angle side. That's the one where it simplifies it pretty well for you. Looks a lot like the original one, right? Area of a triangle is equal to 1/2 little a times little b times the sine of C, where none of the letters match. That's how you know you got that side angle side going on. So again, this is just a plug and chug problem. You substitute it in and let the calculator do the rest. 1/2 times 3 times 2 times the sine of 110. If you make these out to be too terribly easy, then you forget to check certain things on your calculator. What should you make sure you check on your calculator? Degrees, yes. Make sure it's in degrees. And you get what? Don't just write down my number. Make sure you type it in, and that's what you got. We're good to go. Okay, we're good? Yes? I will take that as a yes. All right, so now we have a triangle. It has angle A. Well, we know there's an A and a C because of the way this is written. We don't even know what the third letter is. Most likely it's B. So we'll use B. So A is 50, C is 20, and little a is 3. So this is your angle side, which means that the area of the triangle is equal to the side we know, which in this case is little a. The side we know could be little b, but it is little a. So little a squared times the sine of b times the sine of c, all over 2 times the sine that matches this, so it's the sine of a. So in order to do this, you have to have all three angles. Easy to do. We know that the measure of angle b plus 50 plus 20 equals 180. So that gives me 70, which means the measure of angle B then is what? 110. So now I just substitute it all in. The area of the triangle is equal to the side you know, 3 squared, times the sine of B, which is 110, times the sine of C. So notice that it's the two angles that are on either side of that side. That all goes in the numerator. I totally wrote C instead of 20. Sine of 20, all over 2 times the sine that's across from that, which is 50. And then you can let the calculator do all of it. So go ahead and type it in so that we can make sure that we're all using our parentheses correctly and everything else we need correctly. It's really important, especially on this one. Because it's nice that you can do it all in one step, but not if you are totally messing things up. And if I need to show you how to type it in, I will. Just make sure that always on these, your numerator and denominator are completely in parentheses, like so. Depending on which version of the calculator that you are using, this opens a parentheses here, so you have to close it. This opens, so you have to close it. This opens, you have to close it. So what we get here, what I got, 1.888. Is that what y'all got? Yes? Okay, good. Units squared. So if you did not get that, let me know or double check what you typed in, but please, please make sure you're actually typing it in so that you know how to do it. We're all good? Okay, so you work on the last one while I pass out the homework. All right, that is what I got for that last problem. Do y'all agree with that? Can all do that? I mean, it's really, here's your formula, substitute it in, make sure you're using the right one with the right information, and you'll be fine. Okay, we all good? Awesome.